In for repair today is a Philco 41 and 265 radio. The first thing we're going to do is remove the knobs. One thing I like to do before removing wires from terminals is to color code them so I know where they connect when I put the radio back together. First, I'm going to unscrew the wires from the terminals of the radio chassis. And then remove the antenna wires. Next, I'm going to remove the speaker plug from the speaker. And then next, I'm going to unscrew the screws that hold the loop antenna in place. And remove the antenna. Next, I'm going to unscrew the screws that hold the chassis to the cabinet. And one thing I like to do is pick up all my screws, nuts, washers, and put them all in a cup so I don't lose them. Next, I'm going to remove the chassis from the cabinet. There's the front of the radio. Here's the back of the radio. Next, I'm going to remove the tubes, and as I remove the tubes, I want to make sure that the tube number is on the tube. If it isn't, I'll use a Sharpie to write the tube number on. Even though this cabinet has a sticker on it that shows the tube locations, I like to write down the tube numbers right next to the sockets. So we'll remove this first tube here. These are locked tubes, so they're a little bit hard to get out. This tube is a 7A4. It's very hard to read on top. So what I like to do is write the tube number on the tube. So I'll put 7A4 on the tube. And then I'll also write it on the chassis here. The tubes are removed. I've put the tube numbers on the tubes because they were hard to read. I've also put the tube numbers on the chassis. Now we're going to turn the chassis over and see if this radio has ever been repaired. So let's turn it over here and take a look. So if you look at it, you see some original parts. They have Philco on them. These are all original parts. This filter capacitor here, electrolytic capacitor, has been replaced, as has this one over here. And then these black capacitors are also replacements. So looking at the overall chassis, it looks pretty good. I see that this has some old rubber insulated wire that sometimes flakes off. This one looks in good shape, but we'll take care of the ones that are in bad shape later, either replace them or coat them with some rubber restore that I put on the wires. Okay. Next, we're going to test the tubes. The first tube I have here is an 84 rectifier tube. So I'll find it on the roll chart here. And then the roll chart tells you all the settings for this tube tester, which is a triplet model 3444A tube analyzer. So we'll go ahead and go through the settings. Stop. So next we're going to go through the settings for this 84 tube. First setting is 6.3. Next setting is 28. Next setting is 6. Next setting is 9. All of these settings are the elements of the tubes. 19403, 19403. And the next 5 settings for the tube elements are 2, 0, 0, 0, and 0. Next we'll turn the tube tester on, insert the tube into its tube socket here. What I like to do is hold the test value down and watch the needle go up. Make sure it's going smoothly. I like to tap the tube, make sure the needle doesn't fluctuate around. So that's good on the first test. That's one plate inside of the tube. The other plate I hold down values 1 and 2. And it looks like for this tube is no good. It's not passing the other element test for the rectifier section. So this tube is bad. We'll go through the short test, see if it has a short. What I'm looking for here is see if the needle jumps off of infinity. And it shows a short on the cathode because this does not have a independent cathode. Oh, sorry, I made a mistake. Next, I'm going to go through the short test for this tube to see if there's any shorts. So I'm going through each of the sections of the tube. Let's do it again. Next, I'm going to go through the short test for this tube, for each of the elements that are inside of the tube. Those were all grids and plates inside of the tube. The next test is going to be for the cathode that is inside of the tube. And for this tube, it shows a short. So this tube fails. Pause. This tube fails for 2 reasons. One of the rectifier sections is very, very weak, and then the cathode shows a short, so this tube needs to be replaced. This tube fails for 2 reasons. One of the rectifier sections is very, very weak, and then the cathode shows a short, so this tube needs to be replaced. The next thing I'm going to do is test the power transformer on this radio to see if it is burned out or running hot. The way I do that is I remove the rectifier tube. I've tested all the tubes on this radio and only one tube was bad, and that happened to be the rectifier. So I've removed the rectifier tube. The line cord in this radio had been replaced previously, so it's in good condition, so I can plug the radio in. I'm going to go ahead and turn it on and then let the radio sit for about 15-20 minutes and see how the power transformer does. In doing this, when I turn the radio on, the pilot lights on this radio are both good and they're nice and bright, so I don't worry about any short circuits. I see all the filaments are glowing inside of the tubes. So I'm just going to let this radio sit for about 15 minutes and see how it does. Right now, I don't hear the transformer making noise. It's not making any smell. There's no burning smell coming off of it, so I feel pretty confident this transformer will be in good shape, but I'm going to let it sit here and cook. The next thing I'm going to do is test the power transformer on this radio to see if it is burned out or running hot. The way I do that is I remove the rectifier tube. I've tested all the tubes on this radio and only one tube was bad, and that happened to be the rectifier. So I've removed the rectifier tube. The line cord in this radio had been replaced previously, so it's in good condition, so I can plug the radio in. I'm going to go ahead and turn it on and then let the radio sit for about 15-20 minutes and see how the power transformer does. In doing this, when I turn the radio on, the pilot lights on this radio are both good and they're nice and bright, so I don't worry about any short circuits. I see all the filaments are glowing inside of the tubes. So I'm just going to let this radio sit for about 15 minutes and see how it does. Right now, I don't hear the transformer making noise. It's not making any smell. There's no burning smell coming off of it, so I feel pretty confident this transformer will be in good shape, but I'm going to let it sit here and cook. On the speaker has a field coil, and in this case it has a voice coil. Sometimes there might be an output transformer mounted here, but in this case the speaker plug, or in this case the posit. In this case the power transformer is mounted inside the radio, so the speaker plug here is serving the voice coil. So I'm going to do some resistance checks to see if the field coil and the voice coil are good on the speaker. So first I'm checking the field coil. Field coil measure is about 1.6 k ohms. For this radio, that's normal. Next we'll check the voice coil. Voice coil on this radio is 4.2 ohms, and that's normal because this vintage radio would have normally a 4 ohm voice coil. Next I'm going to remove the speaker. I've removed 3 of the nuts that hold the speaker into the cabinet. I'm going to unscrew the last one. And after we remove the speaker, we'll inspect the cone and see what kind of condition it's in. So there's the speaker and its cone. The cone looks absolutely perfect. One issue I run into is this old insulated wire that crumbles off. You see how fragile it is. So what I do is I mix these 3 chemicals together. This is Kai Clean by Keg. This is Service Cement by GC Electronics. And then Belt and Drive Non-Slip, also by GC Electronics. I mix half of this bottle with a 1/4 bottle of this and a 1/4 bottle of this to make chemical mixture to coat the insulation with so it's not so brittle. This is a mixture of those 3 chemicals, and I'll go ahead and coat some of these rubber wires. So I just put the chemical on liberally. And then I'll go through the whole radio and coat all of these. I do this so that the wire insulation doesn't come off. As long as I don't move these wires, the insulation will stay on. If the wires are in really bad shape, then I'll replace those wires. So I've coated all the wires, and now I'm going to start replacing some of the paper capacitors here. I'll start with this capacitor. I like to clip the leads out right against the capacitor so I can see where the leads go. So in case I get distracted by a phone call or something, I know exactly where the part goes. So this part I removed is a kind of scratch away so I can see it. And this one I can't really read, so sometimes I got to use a heat gun. And this one looks like a 0.006 microfarad capacitor. So now I'm going to put this 0.01 microfarad capacitor in circuit. I've already made a hook here in the old lead. This lead here was too short, so I'm going to wrap the lead from the new capacitor around that terminal. So now I'll go ahead and cut these leads to length. I'll go ahead and make a hook in the new capacitor and then put this capacitor in and wind it around the terminal here. And then I'll go ahead and solder it in place. Try to get the solder out of the way. There we go. Go on one side and I'll get this terminal soldered in. Let those dry and then I'll clip off this lead here. We're going to be replacing this electrolytic capacitor here. This capacitor, the negative side is going to the B- bus. I can tell that that's where the B- is because of this wire here with the green trace, a white wire with a green trace going back to the power transformer. And the positive side is going to the rectifier tube down here. Looking at the schematic, someone had to replace the capacitor, which should have been a 12 microfarad capacitor, with an 8 microfarad capacitor. So I don't stock 12 microfarad capacitors, so I'll be installing a 22 microfarad capacitor. Now I'm going to remove the old capacitor and install the new capacitor. Again, I'll make loops with the composite. I'll cut the old insulation back a little bit so I can make a loop on the wire that's installed here. And then we'll install the new capacitor. So I can ask people in the video, which way does capacitor install? This is the negative side, the silver side, and this is the positive side, the black side. Do I install it this way, with the negative side to this lead, or this way? Does anyone remember? I'll let you think about that while I get the lead ready here and install it. Again, when you work on radios, you don't want to get distracted. If you forget how things install, go back to your schematic and try to figure it out. The negative side goes to this lead here. And we'll connect the positive side there. And we'll get this soldered in. Sometimes when I do the soldering, I'll dip my solder in some flux to make sure I get a good solder connection on the old wire. There we go. Get the other one here. Then we'll cut the lead off and we will be done. Another thing I like to do with the parts I install is rotate the part so I can read the value. So if someone comes in the future, they can see what the values are of all the parts. Now I'm going to begin the process removing the capacitors inside this bakelite boat. It's always good to draw a diagram of the wires that connect to any component when it's more than two, just so you don't lose track of how to rewire it after you remove the component. The bakelite boat is removed. Got it sitting here on the workbench. One thing I like to do is take all the parts and put them in a cup so I don't lose them. So now I got the parts in a cup here. These caps that are set in the bakelite boats are encapsulated in tar. There's different methods of removing the tar. You can freeze it, you can heat it out. I just take a screwdriver and dig out the tar to get at the old capacitors and then remove them. It's a messy job, but once the capacitor is exposed, they're pretty easy to remove just by tilting them up with a screwdriver. So I got it tilted up here, and I'll just pull them out. Once the caps are removed, you can remove the old wire leads by pulling them up with some needle nose pliers. After that, I just heat the solder joint and stick a small metal rod through the rivets to open them up so I can put the new components in. Here are the old capacitors removed. The new capacitors have been soldered. I like to stagger them so that the leads don't short out when I insert them back into the bakelite boat. I removed the solder so you can see the light shining through the openings in the rivets so I can install the new capacitors. The new capacitor has been inserted into the bakelite block, and the leads still long are up around the center terminals, ready for solder. Leads have been soldered and clipped off. A lot of people fill the void with silicone, fill the boat with silicone. I just like to leave it empty like this, in case in future if the capacitors go bad, they're easier to remove. The rebuilt bakelite block has been reinstalled in the chassis, ready to reattach all of the wire leads. All the leads have been reattached and soldered to the bakelite block. All the capacitors in the radio have been replaced. I don't replace the mica capacitors because I generally find those to be good. Now I gotta check the resistors. I like to replace all the capacitors because the resistance will be extremely high, and on the yellow capacitors, if you measure the resistance, it'll go to an open circuit on an ohm meter. So I can check all these resistors in circuit. This 1K resistor looks a little bit bulged. I'll measure the resistance here. Measures a little bit high at 1.3K. I'm going to go ahead and replace that, that resistor. These two resistors here, a 220 k ohm resistor and a 580 k ohm resistor, measured a little bit high. All the other resistors in the radio measured within 20%. I usually give higher tolerance or more leeway in rejecting resistors when I measure them, because these are old radios and the tolerance of the resistors doesn't need to be 10%. So I accept sometimes 30% difference in readings. So let me go ahead and show the readings of these resistors. This is the 580K resistor here. So it measures down, measures about 2 million ohms on the scale that I have. And the 220K resistor right here measures 353 k ohms. So I'll go ahead and replace those two. I misread the color codes on that one resistor. That's supposed to be 680K and the other one 220K. So these are the new resistors that I'm going to install. I have the new resistors mechanically installed with the long leads showing, ready to be soldered in. And those two resistors are soldered in place with the leads cut. And in case you forgot, this is the 1K resistor that required replacement. I've got the resistor installed with the leads long before soldering. And the 1K resistor is soldered in. If you're wondering, this is a 2-watt 1K resistor. The other resistors that I installed are half-watt. There was another 220K resistor that measured around 335K, so I had to replace that. In all my years of working on radios, I don't know why it is, but these 220K ohm resistors at a half-watt or quarter-watt, they always seem to be bad. It's very, very strange. Other values are usually pretty much spot on. Sometimes where the cloth covered wire that's going to the speaker, there's a speaker plug there, going to the speaker gets frayed where it passes through the chassis here. I'll coat it with liquid tape, which I have here. Just some regular liquid tape from Home Depot or Lowe's. And put that on the wire, and then take some electrical tape, wrap it, stick it through the hole, and then take a wire tie to hold it in place. Keep it from shorting out on the chassis instead of replacing the whole wire. In rewiring or resoldering this messy lead, I saw there's a capacitor under there and a resistor that I didn't check. To remove and replace this capacitor, I'm going to have to temporarily remove this RF coil here, get it out of the way, because the capacitor is directly underneath it. I got that coil tilted up out of the way, and now I can replace the capacitor and check that resistor. I got that capacitor installed. It's kind of a bear to get in, but I finally got it in. I got the coil resecured to the metal tab on the chassis. All the capacitors have been replaced, out of tolerance resistors replaced, and that one power resistor that looked kind of like it had handled too much heat once been replaced. Before I power up the radio, I like to measure the B+ resistance, make sure I got no short circuits on the B+ line. So I go ahead and do that. Looks like my meter's fading away. There it is. So it shows an open circuit, so I have no shorts on the B+ line. So I'll go ahead and power up the radio and measure the B+ at certain points on the B+ bus. Make sure I got plate voltages on the tubes. Before I power up, just want to talk about my supply here. This power strip is supplied by my isolation transformer. I've got on the floor down here so I don't have any shock hazards. I don't have a variac, so I always power up my radios with straight line voltage. The reason I don't have a variac is when I return the radios to my customers, they're going to be turning these radio on with full voltage applied, and a variac to me is defeating that purpose. I want to see how these radios handle the inrush. I'll go ahead and turn the power onto the radio, and as the radio is warming up, I like to watch the B+ voltage. Here it is, the rectifier tube is heating up to full voltage, and then its voltage is collapsing as the output tubes pick up. So this radio is supposed to operate around 200 volts on a B+ line, and it looks like it's pretty close to that, so I'm not too worried. Just go ahead and measure some voltages here and there. There's one of the screen grid voltages here. It's hard to tell on these Loctite tube the pin layout because you can't really tell where the key is too easily. Another one of the plates on the 77 tube. It's kind of hard to make this video measure voltages with holding the camera, so I'm going to turn this off and measure the voltages. These are the sprays I use to clean the controls on radios. The red label deoxit I use for contacts, and the green label for movable volume controls, tone controls. The deoxit brand is made by Cake Laboratories. There's also another one, basically the same name, Deoxid by GC Electronics. Also use this. It doesn't work as well as the Deoxit by Cake Laboratories. Also at Home Depot and Lowe's, they have this 2-26 brand multi-purpose precision lubricant by CRC. It works okay, but not as well as the Deoxit brand. The Deoxit brand lasts about a year in operation with a radio. For these other brands, they might last a couple months before you need to spray the controls again. This is the audio cable added to the radio to play any audio device through: a smartphone, MP3 player, CD player, phonograph. So this is a diagram I drew up a few years back, just showing how I connect it to the radio. I connect it to directly to the volume control. I don't add a switch to switch between the radio and the audio cable. I just tell customers to tune the radio to somewhere quiet on the dial, because when you plug in the audio device, its impedance is very low compared to that of the radio at the volume control circuit, and it pretty much drowns out the radio. And here's the connection, the physical connection to the volume control. Ground on the lower lug of the volume control. The two resistors mixing the stereo signal through the red and white wires to a mono input on the high side of the volume control. And then the plug here, stereo plug that goes into the audio device. I coated liquid tape on the bare wires of the audio wires and resistor leads go into the volume control to provide a little bit of isolation, keep it from shorting out on the chassis. Before aligning the radio, I need to make sure the dial pointer is lined up correctly with the dial. These first marks right here, the dial is supposed to line up with, and you see the dial pointer is a little bit off, so I'm going to slide it over until it lines up with those marks. Now the dial pointer is lined up with those first marks on the low end of the dial. I'm going to measure critical points so I can do the alignment with a tape measure, and then put those marks on the back of the dial on the chassis, because this dial plate is mounted inside of the cabinet, so I can't use it as reference. I don't want to put the radio in and out of the cabinet trying to do the alignment. Using a tape measure on from the low end of the dial, these are the distances from those marks to each of the frequency positions for AM, police, and shortwave. The radio is now connected to my signal generator, to the antenna of the radio for IF alignment. I can connect it to the antenna because there's not an RF amplifier ahead of it. If there is an RF amplifier, you need to connect it to the grid of the mixer tube. Also, I've connected to the speaker an analog meter set on AC scale, lowest scale, so I can do the adjustment by watching the swing of the needle. These are the 3 IF cans I'll be aligning here. There's 2 adjustments on the first can, only 1 adjustment on the second IF, and 1 adjustment on the third IF. So I'll go ahead and turn my signal generator on. I'll try to talk a little louder because you can hear the tone. For the first adjustment, I need to use this tool here that has a little metal slot on the bottom to fit over the screw. So as I make the adjustment, I'll go over to the meter so we can watch the swing. Looks like that's it for that one. Next I'll adjust the screw here on the first IF. And go back over the meter. It's about there. I'll just go to the second IF screw and adjust it. That looks pretty much on. Then the third IF. Looks like about there. So now the IF has been aligned on this radio. Next I'm going to do the alignment of the AM, police, and shortwave bands to the dial. The dial is marked, so I can now do the alignment of the AM, police, and shortwave bands. The chassis has been marked with the frequency settings for the trimmers, so I know which ones to adjust when I adjust the radio to the dial. The chassis has been marked with the frequency settings for the trimmers, so I know which ones to adjust when I adjust the radio to the dial. Got the signal generator connected, the dial set to 600 on the AM band. Now I'll adjust the pattern here for maximum volume. Now the generator is set to 1500 and the dial set to 1500, and I'll go ahead and adjust the trimmers for the 1500 setting. So I got to reach in here. There we go. This is the oscillator setting. And this is the trimmer on the antenna. Now the police band trimmer will be adjusted. Dial set to 6,000 kilohertz. See if I can squeeze the screwdriver down to the trimmer. There we go. I'm not sure how this is going to adjust. hear something there. I'll keep adjusting to see if I can hear something else. So I'll be getting a lot of image frequencies. Looks like it's right there. I'll leave it at that. Now I got the generator set at 12,000 kilohertz for the shortwave adjustment. Dial set on the shortwave setting at 12,000 kilohertz. Now I'll try to get to that adjustment. Let's see. This one's kind of hard to get to. Don't have a long enough screwdriver. Can't seem to get it on there. Let's see if I can. There we go. Let's see if it'll turn here. Oops. Boy, it's sensitive. The radio called for a antenna adjustment for the shortwave band, but this radio didn't seem to come with it for some reason. Maybe it was a different production run. I'm going to apply Howard's Restorative Finish on the Philco radio here. It's got kind of a bad worn spot right here. Let's see how the Howard's does. Pour a little bit out and spread it around with a cloth. And that's the magic of Howard's. Looks like that bad spot is completely gone. I'm about to install the speaker. I don't want to reuse these spring nuts, so I'm going to put in regular steel nuts to mount the speaker inside the cabinet. So the speaker is now mounted back in the cabinet with the 4 nuts with the washers behind them. And these spring nuts are going into the trash. I've reinstalled the loop antenna in the Philco radio. It's a little bit tricky on how to do that with all the fittings, so you get it right when it turns. There's a little bit of tension. Now it'll be time to reinstall the chassis. Clean the diode glass with some water and a soft rag. I don't like to use any kind of cleaners on this because sometimes the paint will just come right off the glass. Chassis is installed back in the radio cabinet. Speaker wires are terminated. Speaker plugs plugged into the speaker. And we're ready to turn it on to see if it still works. Sometimes the springs in these knobs wear out and deform. Sometimes I can bend them and get them back into shape so that they'll fit on the shaft. But this one just wouldn't do that. So I use plastic or sheet metal and insert that and glue it in place until I get enough friction and holding power for the knob to turn the shafts. Now it's time to power up the radio, see how it works. These take about 30 seconds or so to warm up.
Second best team I've ever seen them. I'm with you. I would put them.
So this is the AM band. It's kind of going through. It's nice and clear. Tone control there. Shortwave bands. This is the old police band here. It's really nothing.
after 9/11.
Station there.
In any case,
寫過一篇關於張淺田嘅文章，佢認為張淺田嘅問題係佢嘅音樂做得非。
I don't think I set any of the preset stations. A little dirty. Maybe I'll spray those some more.
It's nothing serious.
Here's the radio on the preset push buttons. I added a label for the on switch. Try to get the words on and off on there, but it was just way too small for the window for the station tabs.
It's a burden. It's not. It's supposed to be something small.
So I just set a couple
something
stations
and
here.
making it.
as always, thank you.
You know, put them all in one big bag.
Guess what? We had to make a huge moral compromise. We had to.
Got the iPod connected. Again, the audio cable is directly connected to the volume control, the audio circuit. So I try to find somewhere quiet on the radio dial. The police band seemed pretty quiet. So I'll go ahead and turn on the iPod here. To me, this is the way to use these radios. There's not much on AM anymore, and really nothing on shortwave. So it's nice to play old radio programs, your music, period music, on these old radios, listening to the soft tube sound. The discussion was a little bit too tight around the on-off switch. It was sticking, so I had to file that out a little bit. Filed a little bit